Okay, so I got cut off in my last video, so I'm going to finish off this problem where I was trying to find R, and so I divided both sides by 10,000 to get 2 equals e to the r 2/3, and then I'm going to take ln on both sides. Ln and e will cancel out, so that gives me ln 2 equals r 2/3. So what I can do is multiply both sides by 3/2, and that'll be r. So I'm going to go to my calculator. I'm going to type in ln 2 times 3/2. I'm putting 3/2 in parentheses, and that's giving me 1.0397, and that's going to be my rate. Okay, so let's look at radioactive decay. If you're in chemistry, I'm sure you are quite familiar with this. And what I have is the formula, so I'm definitely write that down. M sub 0, again, anything with sub 0 is your initial. So initial mass with the half-life. So your R is ln 2 over h. This is always ln 2. That's how you're going to find your R. So it's m sub 0 e to the negative RT. So what we're going to do is find the rate. These are just some half-lives. You don't have to write these down and memorize them, but if a problem is telling you the half-life, know that you need that piece of information. Okay. So we have this element, and we know its half-life is 140 days, and we want to know the sample size is 300 milligrams. What we want to do is create an equation that's going to represent this situation. So your m sub 0 is your initial amount. In this case, it's 300. It's the initial amount of that you're starting with. My formula uses e, so it's m sub 0 e to the negative RT. We have to find R. R is your ln 2 over h. So that's 140 in this problem. So I'm going to go to my calculator again and type in ln 2 divided by 140. And I'm going to get 0.00495. So for this first part, it's 300 times e to the negative 0.00495t. If you want to know how much is left after 1 year, all you do is plug in your time into that. Now again, you want your units to be the same thing. So my half-life was in days, so I'm plugging in 365 days. My half-life was in years, and I can plug in the 1 year. Okay, so be careful with that kind of stuff. You always want units to match. So that would be 49. If you want to know how long it will take for the sample to decay to a certain amount, then we're going to set up an equation. I'm going to start with my equation that I came up with. And set that equal to 200. Divide both sides by 300. So that gives me 2/3. I'm going to take the ln on both sides, which is going to leave me with just this decimal. And now I'm just going to use the calculator. I'm going to go ahead and type in ln of 2/3, hit enter, and then divide by negative 0.00495. And I get 81.9. So that's how many days it will take for this element to go from 300 to 200 milligrams. Okay, so here's another application, Newton's law of cooling. And what this law has is the initial temperature that you're going to start with, or not the initial really, but the temperature of the surroundings. Okay, so T sub S is like the temperature of the room that you're in. Your D sub 0 is the initial temperature difference in that room versus the object you're looking at or holding or whatever. It'll make a lot more sense once you see a word problem. And then your negative KT, K is just a constant. So what we're going to do is come up with an equation. So I've got the situation where I have a cup of coffee and it's 200 degrees. The room that it's in is 70 degrees. Obviously, like, the room is going to affect how quickly your coffee cools. After 10 minutes, the temperature of the coffee is 150 degrees. So, using this formula, I'm going to have to just plug in all this information, and 70 is the temperature of the surroundings. That's your T sub S. The 130 came from me doing 200 minus 70. That's the difference, okay? And then the rest, that's going to change based on, what other factors I have. So this is my general equation. If you want to find out the temperature of the coffee after 15 minutes, all you have to do is plug in 15. Now, where did this number come from? That's your K. And to get that K value, what we'd have to do is use this information that was mentioned earlier on in the problem, that after 10 minutes, the temperature of the coffee is 150 degrees. So what I'm going to do, instead of 70 plus 130 times e to the negative 10 K, okay? So I'm using this formula, and I know my time is 10 minutes, and I don't know what my K is. So I have to solve this equation in order to figure that out. And so I'm going to grab my calculator, and I'm going to solve for K. 150 minus 70 divide by 130. So I'm getting e to the negative 10k equals 0.615 something, okay? Keep going or leave it either way. I'm going to take the ln on both sides, so that's going to make this e disappear. I'm just going to throw an ln in front of there because I'm running out of room. And so all I have to do is do ln of this number, 0.61538, and I'm going to divide by negative 10. And that's where this number is coming from. Okay? So a lot of times these problems will give you some little bit of information, and you can use that to come up with a constant to use to predict other problems. Okay? You've done this before with like linear regression, making predictions. Okay? You know something about past information, use that to figure out something else. The most important thing is really just being able to do this algebra and apply the skills. I know that a lot of these application problems doesn't make a whole lot of sense, or you're having a hard time setting up the equation. And I'm not going to expect you to set up super crazy hard ones, but I do expect you to be able to do the math behind it. Okay, so let's look at a super realistic word problem, something that, anyone could do. Okay, so, we're not looking at physics and chemistry, because not everyone's going to have to do those things, but money. Okay, that's something everyone has to deal with. So we talked about this formula early on, and super realistic problem, what I want to know is, if I invest $5,000, how much time is it going to take for my money to double? How long do I have to sit there and let it be? With these, factors, okay? So I'm going to start with $5,000. My 1 stays the same. My rate is 5%. My n is 2 to the n t. I don't know time. Okay, I don't know how long it's going to take. That's what I want to figure out. This is the goal, guys. We want you to be able to solve a real life problem that has a variable in the exponent. Okay? So what I'm going to do is take 10,000 and divide by 5,000. Obviously, that's only 2. So here's where it gets kind of gross. Obviously, this is not a nice number. So let's just go ahead and type that in. What is 1 plus 0.05 divided by 2? Now what I'm doing is I'm putting this in parentheses. And so I'm going to get 1.025 to the 2t. Now I can take the log or ln on both sides. Make sure that when you bring down that 2t, keep your log here. So what I'm going to do is I'm going to do log 2 divided by log of 1.025 Then I'm going to divide that by 2, which gives me 14. Make sure that your answer makes sense, okay? If I'm going to get my money to double on a low rate like that in a short amount of time, something's probably not right. 14 years is kind of a long time to watch it double, but it wasn't that much money to start with in the beginning, okay? So, here are some problems for you to try in your book. These are actually out of the last section, but they're totally relevant to what you're just doing. This is more like the interest stuff, solving for money. So how much time will it take for my money to become this? Or maybe what rate would I have to have in order for me to have this much money? And then you're getting into some of those population, bacteria, half-life problems. Okay? This is just the bare minimum. If you need more practice, let me know and I will find you some.